start a topic of the DAR, that is traveling salesman person problem. It's a problem basically which is in which there is a salesman who needs to cover the number of the cities. He needs to be started from a starting city, and after completing the tour, he needs to return back to his starting city. So this is a traveling salesman person problem, and we are having a number of approaches in the DAR to solve this problem. The very first one is the brute force approach. The next one is DAC, that is divide and conquer approach. The third one is DP, that is dynamic programming approach. The fourth one is greedy. The fifth one is backtracking, and the sixth one is branch and bound. The traveling salesman person is a problem that can be solved using DP approach. It can be solved using branch and bound also. So here we are solving this problem using branch and bound technique. Now what is branch and bound technique? It's a technique basically in which there will be a state. After that there will be a number of the branches, and there will be a decision basically after this state which state we should cover. If a salesman is starting from a city, for example from the Mumbai, or you can say from the any of this city, then from here he can go either to the B state, he can go to the C state, he can go to cover the D state. Where he need to go? This is a decision problem basically. So when he is trying to cover the city, the question is which city he should cover. It depends upon the cost. The cost should be minimization. So it is having the two things. One is to optimize the problem. So we are saying it's an optimization problem in which either we need to minimize or we need to maximize. If we are saying about the profit, if we need to cover the profit, then we should maximize it. Profit should be maximum. If we need to talk about the cost, then it should be minimum. If we are saying about the weight of anything, then it should be minimum. So according to this, the TSP is an optimization problem in which a salesman has to cover the number of the cities starting from the initial city and covering a tour and returning back to the starting city with the minimum cost. That is our main problem. That is the goal of this problem. Now what is branch and bound technique says? It says if we are branching from the A, we are covering either we can go to B, either we can go to C, either we can go to D. After finding the cost, if the state is having a higher cost, then we have to put a bound over here. We cannot proceed that path. If C is also including A to C cost is also high, then we will put a bound over here. We cannot proceed for this path. Then we have to proceed for the D if it is having the minimum cost, for example. Then the further branch will be the what can be the possible solution. So that's why it's a branch and bound. Putting a bound on the path which is incurring with the highest cost, and branching for the possible solution. What would be the possible solution from one state to moving toward the next state? For example, this is a problem having the number of the cities like A, B, C and D, and we are mentioning it row by column here, and we are putting infinity on the position where there is no direct path. So A to B is 10. It means if a person is moving from A to B city, the cost is incurred with the 10. If we are moving from A to C, then the cost is incurred with the 5. A to D, the cost is 3. In the same way, we are converting the graph to this matrix. After converting this, what is our main purpose is to find the base matrix. Now, what is this base matrix? This base matrix will be worked here as A cost incurred with the A. If we are moving with the A. Now, what it says that in the initial matrix, we need to do the reductions here. In the branch and bound method, we need to do the reduction, and the reductions first we will do toward row, then we will do toward column. When we are doing the reduction toward row, it means we need to cover, we will select the minimum value, whatever the minimum value in the row. For example, in the row 1, the minimum value is the 3, so we mention it here. In the second row, the minimum value is the 7, so we will mention it here. In the next third row, the minimum value is 1, we will mention it here. In the fourth, the minimum value is 2, we will mention it here. So if we will calculate this reduction cost by the row wise reduction cost, then it will be 13, and we are mentioning it with the RC, that is the row reduction cost basically. RC is the row reduction cost. So if we will reduce the matrix, we will subtracting this value from all the row. Like 3 subtracted from all the cells. Infinity will remain the same. 10 minus 3 is 7, 5 minus 3 is 2, 3 minus 3 is 0 here. In the similar manner, we are trying to reduce it. We will minus the 7 from the second row, we will reduce 1 from the third row, we will reduce 2 from the last row. If we will do this, we will get this matrix. Then after that we will do the column reduction. Now what is column reduction? Similarly, select the minimum value from the column. Like from the column 1, the minimum value is in this column is the 0. So we will mention it here. In the second column, the minimum value is the 1. We will mention it here. In the third, the minimum value is the 2. So we will mention it here. And in the last one, the minimum value is 0. So we will mention it here. Now, if we will reduce the same matrix, row reducted the matrix in which we have done the row reduction previous matrix, if we will apply the column reduction, the total cost is incurred is 1 plus 2, that is 3. This is the column reduction cost. Now, if we will add it, 13 plus 3, the total cost for the starting from the A, that is 16 here. Now, it is the base matrix which will be worked for the further branches, that how to go from A to B, how to go from A to C, from A to D. Starting from A, the main cost is 16, which will be added in each and every part. Now, when we will reduce this value, 0 from this column, 1 from this column, 2 from this column, 0 from this column, we will get this matrix here. When we will reduce 0, means minus 0 from the first column, no changes here. If we will reduce second column by 1, it means we are subtracting 1 from the second column. 7 minus 1 is 6. Infinity will remain the same. 5 minus 1, 4. 1 minus 1 is 0 here. This is 0. 2. Third column will be reduced by 2. Means we have to minus here 2. 2 minus 2, 0. 2 minus 2, 0. Infinity will remain the same. 6 minus 2 is 4 here. The fourth column reduction by 0. It means the 0, 0, 8 will remain the same and infinity will remain the same. Now this is the base matrix, or we can say the parent matrix, which you will use from A to B path, which you will use from A to C path, which you will use from A to D path. Now there are 3 branches. Out of that, we will going to select the one which is having or including the minimum cost, and we will put a bound that path which have maximum cost. So that's why the technique is branch and bound. Putting a bound over the path, that is including the maximum cost here. Now what we need to do, we need to we need to solve for A to B. Similarly, we need to solve for A to C, for A to D. Now let's proceed for finding the path or the cost that is involving in the path A to B. For A to B, what we need to do, how we will study the A row and B column. It means A row will have the infinity, B column will have infinity, and B to A cell will have infinity. Rest of the values will be same as of our parent matrix. So if we will copy the values, we will complete this matrix. It will like 0 and 0 here. In the C column 0, 0, infinity and 4, and here 0, 8 and infinity. Now how we will reduce it? We will need to again apply the row reduction and column reduction. For example, if we will do the row reduction, then if a row is having infinity, there is no need to reduce, it means there is no reduction. In the second, there is 0, so there will be no reduction, the minimum value is 0. In the next one, there is a 0, so there will be no reduction in the row. Here there will be a 0 again, so there will be no reduction in the row. So there will be no reduction. So row reduction cost will be 0 in this path here. Now let's check for the column reduction. Similarly, the column is having the 0, so there will be no reduction. This column is having infinity, so there will be no reduction. In this, the value is 0, so there will be no reduction. And this cell will have the value 0, so there will be no reduction. So there will be column reduction cost is 0 here. Now how the total cost from A to B will take? We will take the previous cost plus row reduction cost plus column reduction cost, like 16, column reduction cost 0, row reduction cost is here 0. So here the row reduction cost is 0 and the column reduction cost is 0. So 16 is the previous cost for A, row reduction cost 0, column reduction cost 0, plus A to B cost in the parent matrix, that is 6. If we will add it, then we will get a cost of 22. It means if you will move from A to B, the cost is incurred here 22. Now similarly, we need to solve it for A to like C. Then we need to solve it for A to D. If we will solve it for A to C, then A row should be infinity, C column should be infinity from the parent matrix. If we will remove these cells, then we will update this row reduction cost, we will update this, and we will update this cost also. So the A column will be infinity, and in A to C column will be infinity. Then C to A cell will be infinity. Now complete this matrix on the previous one. Like here is 1 and 0. Then there is infinity, 4 and 0. And in the D cell there is 0, 8 and infinity. The matrix will be completed. Now if we will reduce the cost, we will see in the row there is infinity. So first row there will be no reduction. In the second there is 0, so there will be no reduction. In the third one row, infinity, 4, infinity and 8. The minimum value is 4 here in the third row. 0, 0, infinity, infinity, so there will be no reduction. So it means here will be the row reduction cost incurred, that is 4. And if you will reduce the matrix will be coming like A, B, C, D, A, B, C and D. The same first row will be the similar this. We need to write it down. Second, there will be no change. And in the third row will be reduced by 4. If you will reduce the third row by 4, means minus 4 in the third row. Infinity, there will be 0, there will be infinity and there will be 4. Last row will remain the same. Now this is the reduction cost for A to C path. Now check it for the column reduction. Here it is 0 minimum, there will be no reduction. 0, so there will be no reduction. Infinity, so there will be no reduction again. In the fourth, there will be 0, so there will be no reduction. So the column reduction cost is our 0. So how to compute the cost for A to C? Initial cost, that is 16. Row reduction cost is 4. Column reduction cost is 0. And we are finding for A to C. So A to C in the parent matrix is having the cost 0. So we will add it. So the overall cost will be 20 here. So we will mention it here in the state space tree, that is 20. Now we need to compute it for A to D. Overall cost, initial cost, row reduction cost, column reduction cost plus A to D cost from the parent matrix. This will be 16. This we need to find out. This we need to find out. A to D cost is here 0. So let's do it for the A to D matrix. For A to D part, here I am removing all the cells here. I am removing this. I am removing this value. We will update it. And we will check it further for this thing. The parent matrix is here, we are not removing it, right? So, A to D path we are checking out for A to D, means A row and D column should be infinity and D to A cell should be infinity. Fill the complete matrix again, 1, 0, then infinity, 4 and 0, then there is 0, infinity and 4. Now let's check it out for the reduction. For the row reduction, first column, first row, no reduction. Second having 0 minimum, so no reduction. Third one having 0 as minimum, so no reduction. It is having 0, so no reduction. Row reduction cost is 0 here. Proceed for the column reduction. In the column there is 0, so there will be no reduction. Having 0 as minimum, so no reduction. 0, so no reduction. Infinity, so there will be no reduction. So overall column reduction cost is again 0. So 16, row reduction 0, column reduction 0, A to D overall cost from the parent matrix, that is our 0 here, this one. So the overall cost will be 16. Now what the state space tree says, this is a state space tree. If we will traveling, if a salesman traveling from the A city, he need to cover either B, C or D. Out of 3, he will go from A to D. Why? The cost is incurred here, the minimum one. Now again the D, on the D city, when he covers the D, there is again the possible outcomes that A, then D, then further either he can cover in B or he can cover in C. So again we need to solve the problem for A, D and B, for A, D and C. Now what we need to do, if we will solve it for A to D, it means that the A row, D row and B column. ADC means A row, D row and C column. D to B cell should be infinity, B to A cell should be infinity, C to D cell should be infinity, C to A cell should be infinity. If you will solve it in the similar manner, then we will try to find it out what cost will be having the minimum. As we have solved for A to B, A to C, A to D, similarly we need to solve it for A, D, B path, we need to solve it for the A, D and C path. By solving A, D and B, what we need to do basically, A row infinity, D row infinity, B column infinity, B to D cell infinity, B to A cell infinity. Similarly apply the same row reduction and the column reduction, and consider as we are taking the A to D, so now this matrix will be the main matrix which we need to take as a parent matrix. Now the parent matrix has changed, this will become the new parent matrix for the next path, for the next branch, that is A to B, ADB or ADC. For this path this will be act as a parent matrix. Apply the same row reduction and the column reduction cost, same procedure we need to apply, then we will get the overall cost is here 16 and here 25. Again the salesman needs to travel along the minimum, the stage which is incurred with the minimum cost, so it will follow this path. After covering A, D and B, there is only one city which you need to cover, that is the C1. Then we need to solve it for the A, D, B and C. Here A row, D row, B row and C column. All we need to put infinity, and the last matrix which we get all with the infinity values, and the final cost which we will get is 60. In the similar way, when we need to write it on the path, the overall path will be the A, D, then B, then C, then A. This is the final path incurring with the cost 16. When we are trying to solve it for this, the whole matrix will have the infinity value. Thank you very much.